Oh my gosh. Okay, I apologize, folks. We were kind of drifting through. I'm walking through things. Nobody's hearing what I'm saying, and I'm talking and talking. So now, hopefully, people actually hear what I'm what I'm saying, so we can go back through all that stuff. Okay, I apologize, folks. I'm actually, for the first time, I am running in a dual mode where I'm actually got a co-presenter here. Nader David is going to be joining me in a few minutes, and I guess when I went into my streaming presentation, I must have muted the wrong microphone. So apologies for that, everybody. So let's talk again. I'm sorry, I had a really good ramble there where I was talking about aligning, single table design with the fundamental concepts of Amplify and GraphQL. And so, I'll summarize this discussion again since none of you heard it. That's okay. Nobody will be hearing it twice. Again, when you look at the Amplify community and GraphQL implementations within that community, there's a lot of debate around single table design and whether or not we should go with multi-table for single table. There's a lot of advantages to both cases, right? I mean, if I've got an application where I've got a greenfield environment and I don't know what my application's access patterns are going to be, I don't know what it is I'm trying to actually build yet. I have some idea, but not maybe a fully clear idea of what this model is going to look like. Then being able to break things up into entities, right, and being able to kind of create a table per entity is actually not a bad approach. It's a pretty good approach when we are when we are well understood with the access patterns we're trying to build, when we have user stories that are well defined, and I know exactly what it is I'm trying to build here, or I have a pretty good circle around these access patterns, then when we start to look at the efficiency that we can be gained in a single table design, it makes a lot more sense. So again, pros and cons to both approaches, but fundamentally, the idea of single table design kind of is woven through the concepts of GraphQL. So if we look at a GraphQL implementation, what does that really mean? Let's go ahead and go back to what GraphQL really is. Let's the bottom line is it's about this type system, right? We're going to define entities. We're going to create queries that are combinations of these entities to retrieve the bits and pieces that are interesting to our application, right? And this is exactly what we're trying to do when we build efficient applications, is work with bits and pieces of data. When we start to talk about NoSQL databases, a lot of people out there believe that that we should model NoSQL databases to retrieve big hierarchies of data, right? Large document structures that are going to give us the full view of an entity. But the reality is applications don't work with data that way, right? Applications work with data in bits and pieces. And when we start to access data that we don't need and start to retrieve data that we don't need when we make queries, then we start to burn a lot of IOPS and a lot of cost at the data layer, right? So oftentimes what we start to do, as you guys know, I'm an advocate of single table design, which is about creating hierarchies of items within partitions that represent groups of data that we're going to be interested in, and then being able to selectively query the bits and pieces of these hierarchies that are relevant to the application. So let's take a look at GraphQL and really how is GraphQL aligned to this idea. And so if you look at the fundamental concept is a construct within a GraphQL framework is this idea we have a type system. We're going to define entities. We're going to define how these entities are related to each other and what are the bits and pieces of data that belong to these entities, right? We're going to describe these things in a big hierarchy, but we're not necessarily going to populate all of the data and store it all together, right? As a matter of fact, GraphQL is an excellent system to look at as a data layer abstraction, right? It's really what it is. It's a way to be able to take your developers and remove them from how the data is stored, how the data is accessed, and instead let them focus on that higher level application layer logic. And this is really something that I've always advocated in my development teams, right? You create a data layer abstraction, we code to the data layer, and then we don't have to worry so much about distributing the knowledge of how things are stored across the entire development team, right? There's usually some subset of people who really understand that. And it's kind of like the same thing with GraphQL. We're going to build these type definitions. We're going to build hierarchies of how these things are related. And then we're going to ask for exactly what we need. And this, again, well aligned to the idea of a single table design. What we have is a mechanism to be able to structure bits and pieces of data across many items, associate them to a single partition, which represents an entity. That entity may be constructed on the index, it might be constructed on the table. Regardless, it's a group of items within a certain partition that really represents an entity or a collection of entities related to an object. And then we're going to query those bits and pieces out of that partition. Again, well aligned here. What we're looking for in our query structure is well aligned to the data structure that we're trying to build, with the single table. And then the last thing we want to do, and this is fundamentally it, right? It's get many resources in a single request. And that's the crux of the efficiency model of a single table design. When you make a single query, you get multiple types of objects. We're going to use those multiple types of objects to populate this hierarchical data structure. So, I mean, fundamentally, the GraphQL constructs are well aligned to single table design. So if you have a pretty good idea of what these patterns are going to look like, then it's going to be a really good idea to put this thing into a single table. And one of the things that I think is important to realize here is that this is not a new idea, right? Understanding how to use the data, how the data is supposed to be structured before we actually start writing code is a pretty common place requirement for most applications. And if you do any kind of search on bad database design, right? All these things that come out, and they're all about relational databases, right? Because that's how people model data. Well, what is it? Poor pre-planning, unable to understand the purpose, or failure to understand the purpose of the data, inadequate normalization. These are the types of things that are fundamental to anti-patterns within database. And doesn't matter who you go Google bad practices for database design. It's always the same thing: poor design and planning, ignoring normalization. Not understanding how the data is being used, ignoring the purpose of the data. We should understand how we're using our data no matter what kind of database we're using. And in that particular, vein, then starting to look at things from a single table design is probably, really should be more considered a best practice, which it is in DynamoDB. However, there are often times when developers don't understand the velocity of their data. They don't understand, how the data is going to be related. I mean, a really good example, from my own background is a time back in the day when I was building a system that ended up getting acquired by IBM for a little company called Meiosis, and we were building our own RBAC, management system for users. And initially, we kind of started out with, hey, users are going to be admins or they're going to be users, so let's just set a flag on the user record, right? Well, eventually you got, users have profiles. Oh, well, those profiles end to be common up across users. Well, let's define those profiles as roles. And so you can kind of see what's happening here is you start to expand the entities that you're building, and you don't know how these things are actually going to be related when you start. And this was a real, greenfield startup, right? And so then I think there's a kind of a different class of application, right? There's this well understood problem that we're trying to solve, and then there's this greenfield area. And when we're in that greenfield area, maybe doing things a little bit more, simplifying things and simplifying assumptions, can be a better way to go, right? So, I mean, again, I'm not going to come down and say absolutely single table is the way we go all the time, every time, versus multi-table. As a matter of fact, even in my single table designs with customers, as we've discussed over the last couple of weeks, there's often times where I'm going to recommend multiple tables. It's always what's best for you at the time. What we're going to talk about today is how do we actually use single table design in AWS Amplify. And we've got a couple mechanisms to do that. And a really cool one that was just recently released was Direct Lambda Resolver, which allows us to now operate across multiple data sources and retrieve data from multiple systems in complex ways and that aren't necessarily supported by the response mapping templates that are provided with the default Amplify. So Notter's going to show us a lot of that stuff, but just so that we kind of go through what customers have done, we've got a couple examples of some Amplify users that actually gone down the single table path with the existing technologies. Rich Buggy's blog, Learn to Build Serverless Apps, has a really nice breakdown of how he went about single table implementations. And it's interesting because his focus was how do I reduce the complexity of managing multiple tables in production, and it was done actually before we had on-demand tables. And I think if he went down the on-demand path, he might make some different choices. But Rich's approach was to more or less put the entities on on the same table, execute query per entity, and more or less his access patterns mirrored multi-table. So he didn't really get a lot of efficiency in the access patterns because, again, he's querying each entity by type and ID. But he did satisfy his top level requirement, which was merge all the tables together, create one table, and be able to drive some efficiency in how he managed those tables. Probably the most graceful implementation that I've seen in the single table is to use those custom response mapping templates, right? And so here's a really good example that Maxwell Russell did. He put a blog post up actually a couple years ago where he described his problem, which was, basically these three questions, right? If I need to search based on value in table A, how do I return information for table B with GraphQL, right? I mean, that's going to require multiple queries. It's going to require iterating across results. If he needs to search a single query based on two fields that are shared across tables, why not use a single table? If table A has a title field and table B has a title field, why shouldn't these things be joined together on a single table? And is there a way to create and return different aspects of a single table in the same GraphQL queries? And so when he went down this, he started looking at this thing. His model was recipes, right? Recipes have elements have ingredients, and the schema definition was pretty straightforward, right? He's got a recipe type. Recipes, again, have elements. Those elements have ingredients. And so he basically created this nice little mapping template to produce those query results. But what was interesting in all of this, when he went down the path of what he's supposed to return, right? He's returning, let's say, for this example, returning a recipe for breadsticks. Breadsticks has some elements. The garlic butter element has two ingredients. It has butter and it has garlic. Now, if we were on a single table in DynamoDB, I could have a recipe ID, right, as the partition key. I could have an element ID hash ingredient ID as the sort key, and that's what was realized here in this exercise, was that a single query from DynamoDB can retrieve the results that include the entire set, the recipe, the top level recipe, and all the properties of the recipe, all the elements, all the ingredients, and I can make one query, and that maps very well to that GraphQL construct of make one query, get many results. So, what he basically built was a response mapping template which iterated through the array of items that was returned from his query, right? His query was basically saying, okay, I'm going to look by ID for recipe, and then I'm going to get a bunch of results. And in the response, as he mapped the results into the response, it returned the structure he was looking for, right? So in this particular case, he's got a structure packed with all the elements and the ingredients for those elements, and he only had to make one query to the database. So again, this is a really good example you guys can go through, but what we're here to do today is talk about an alternative method to this, which was just recently released by the team. It's a really neat technology by the Amplify team. It's called Direct Lambda Resolvers. What I'm going to do is I'm going to go ahead and bring my buddy Nader Dabbit on. He's going to take us through the implementation, where we're going to take the schema from last week. If you guys remember that, let's go ahead and pop that up real quick. You can take a quick look at it. This is the schema we had last week. This is the online shop schema. We have many, many types of objects on the table, many types of objects within order partitions, multiple queries against GSIs with different patterns we went through. And Nader actually took this model. He implemented a direct lambda resolver to support the various access patterns that we had that we went over last week, including a few additional ones, because the patterns we went through last week were all kind of get entity by ID, whereas the patterns that Nader is going to show us today include complex result sets, right, that can contain many entity types. So let me go ahead and bring that Nader in real quick. Where's our... And can you go ahead and share your screen, Nader? You're showing us, you're showing up in the big screen. Hang on one second. Let me...
Absolutely. Let me go ahead and share my screen.
There we go. We got you. So again, thanks, Nader, for taking the time to actually go through this and actually implement this. But certainly, thanks for taking the time to come and show us what's going on here. So why don't you quickly just give us an introduction and tell us what you're going to talk about.
Yeah, absolutely. So I'm actually a big fan of Rick's. I've learned a lot from his talks and stuff. So It's really cool to be on this show with him. And I've learned a lot over the last couple of weeks actually working with him to kind of implement some of this stuff in GraphQL. Really excited to talk about it. I'm actually really excited about the technology that we're going to talk about in particular, because one of the big limitations, in my opinion, about AppSync has been something that we're now addressing. And when I say a limitation, it's more a DX pattern that could be improved. And that's kind of what we're doing. So, and that's kind of enabled us to now build, a little bit more complex, more sophisticated things using AppSync, and do so in a more understandable way and a teachable way, in a way that is actually going to be, a lot easier for a lot of developers and a lot of customers to start using, because it's just a lot easier than it was before. So, when we're talking about AppSync and we're talking about Amplify, so, let's kind of split those two apart. Well, Amplify is more of an open source toolkit for, really full stack developers that can do a couple of things. So the CLI is an infrastructure as code provider or provisioner. So you could think of the Amplify CLI as something like CDK or the serverless framework, in the sense that you use it to kind of create, infrastructure as code. But a lot of customers are actually using other tools to provision their GraphQL AppSync APIs. And either way, whatever way you go about it, there are some trade-offs. So let's say that you are a CDK developer, and what you would like to do would be to kind of provision an AppSync API with a bunch of different types, and you need everything to work together. The challenge in the past was that the mapping template, which is essentially kind of where the operation happens between GraphQL and your data source, that operation was written in velocity templating language. So if you've ever used something like API Gateway, you might have seen VTL in the past, and it's extremely powerful and you can do a lot with it. But the problem is most developers just aren't comfortable with it, because we're used to writing Python or JavaScript or Java or whatever. So, what we've done to now address that is we're going to be, rolling out a set of different features that are going to be giving alternatives to VTL. So the first one that we've actually enabled is the direct Lambda resolver support. So in the past here, let me actually share a slide deck that I've kind of put together. So I'm going to go ahead and click on new share, and it's going to be my entire desktop, but I'm going to go ahead and pop open this slide deck here. Okay, so so this is just going to be a really short intro to kind of AppSync and Amplify, or really just AppSync. So this is kind of what AppSync looks like in a very short overview. You have an API that is an AppSync GraphQL API. It's kind of an API or a GraphQL as a service. It's a backend as a service type of offering. And in your AppSync API, you're going to define your schema, and that's going to have all of the different types and also all of the different operations for updating whatever data sources you have. Now, by default, we support a few data sources first class. So we support HTTP as a data source, so you can kind of map different REST endpoints or microservice endpoints that you already have. You can map a GraphQL request to Elasticsearch, Aurora, DynamoDB, and Lambda. Now, to do this, you have this one area where you have to write a request and a response mapping template. And this is what I was talking about. That is VTL, or velocity templating language. In doing this, you're essentially just doing like a DynamoDB put operation or query or whatever you're used to doing with DynamoDB. For example, if you're using DynamoDB. And that would basically, make the call to DynamoDB, and then in the response mapping template, that would be the data that would be kind of the response. So if you've used like the DynamoDB document client with JavaScript, for example, you might say, do a put item, or you might do a query. That's kind of where this stuff is happening in these mapping templates. But we overwhelmingly are hearing that people don't like to use VTL. People that understand it, they like it a lot because it's very performant and stuff like that. But we do have a lot of customers that don't like it. So that's essentially where we are today. So what we've now done, and in the future, we're actually going to be doing this across all of our data sources. But for now, Lambda now has a direct resolver that maps the request directly into Lambda. So instead of actually having to have this VTL layer, we're just now mapping the event object into the Lambda function. And in that event object, we're going to kind of log that out and look what's there. But you'll have everything that you need to kind of make the operation happen uh, from Lambda. So you're going to have the arguments that are passed into the GraphQL operation. You're going to have things like an info object that tell you the selection set that's been asked for. You're going to have things like the parent. A lot of good metadata is there in that info objects. You'll also have things like the identity of the caller. So if there's an ID token that's been passed in, that will be decoded, and you'll have that available to you as well. So it's a really nice experience, and that's kind of what we're going to be, just kind of focusing on how that works.
So Nader, is it fair enough to say that the direct Lambda resolver, more or less, it just kind of replaces the response mapping template, but it gives the developer a more familiar framework within which to work, right? They don't necessarily have to learn more than here's the context or that's being passed in. Do we feel that that's a more familiar tool for developers, and more or less that's why we're doing this?
So we've been supporting Lambda as a data source with VTL, but in the past there was actually a VTL request and response mapping template into Lambda. So for instance, DynamoDB, if we're going to be interacting directly with DynamoDB from AppSync, we still have that layer there.
Right.
What we're going to be doing to replace that is, instead of having that two parts, a request and a response, in the future, we're just going to have a single operation that is written in JavaScript. It's almost, you could consider it like a Lambda function that's going to be the resolver.
Okay. So I can take basically what we're going to show today with the direct Lambda resolver. I could convert this one-to-one to a response mapping template, for example, if I wanted to go down the VTL route.
Right, yeah. Exactly. Yeah, fantastic. Everything that we're doing can be done in those mapping templates.
That's cool, because that's one of the things we want to make sure that people understand. The single table design is not something that's just recent to Amplify. It's actually something that has been always supported. It's just required a little bit of more knowledge about your access patterns. One of the questions we just recently got, just got on the chat line was, are there any hard rules about when to use a single table versus multi-table? And I think there is really. The one rule that I would say is that if you understand your access patterns well, then you should go down the single table path, because it's going to generate more efficiency over time, and it's going to allow you to scale without having to rebuild your data model, right? And nobody wants to rebuild the data model. So if we understand what we're doing, then let's go down that path. If we don't understand what we're doing and we're not comfortable with structuring our data in the single table, then the multi-table model gives you the ability to kind of say, okay, I'm going to just take the entity per table model, and at least I know worst case scenario performance will be X.
Cool. Yeah. That's helpful. Yeah, I'm going to keep an eye on the chat as well and see if there's anything I can jump in with. But so I guess let's take a look at the table, because you kind of already have shown the access patterns, but how would you actually kind of take that and move it into GraphQL? Well, essentially what we're going to be kind of doing is looking at the different items or the types really that are available in our database. So if we just do kind of like a scan and just get like the first 100 items, and maybe we'll organize these by type, we'll see that we have like a type of customer. The type of customer doesn't really have any other metadata that I can tell. The type of invoice, it has an amount and a date, and then we have a couple of ways that we're going to be accessing this with a couple of different keys. So we have the primary key and the sort key. We also have GSI1 and GSI2. But what we would like to do would be like, okay, how do we kind of map this into a GraphQL API? Well, because GraphQL, like you mentioned, is strongly typed, or it's a typed, has a type system, we would basically create an invoice type, and we would say, okay, what do we need from this invoice? What would we potentially need? And then we would just create those fields. So if we go over to our AppSync API and we look at the type of order, you can see that I've defined a couple of fields here. So we have like an ID, we have an amount, and we have a date. And we can add additional types here. Whatever we would like to return, can just be some type of field on this type. And then all we would need to do would be to kind of say, okay, now that we have an understanding of the data in our database, we have the actual type defined and the types of data that we would like to have for that type. We need to now define a query to query for this data, and if it was a create operation, we would create a mutation. But we're only focusing on queries today. So we would say, okay, we have this type of order. Now, how are we going to access this order? And then we would look at, our database again and kind of understand those access patterns. We would say, okay, we might want to operate on GSI1. We might want to operate on GSI2. We might want to be using the primary key and the sort key. And then we would create essentially the same names of the access patterns that you talked about earlier. We just kind of define those here. And then we're going to now, after this, kind of walk through how this actually happens, through the AppSync API and Lambda and DynamoDB. So how does that look? Do you have any questions, Rick?
No, I mean, it looks pretty straightforward. So these map one-to-one to the access patterns that we had in the PowerPoint last week. It looks like there's a couple of new patterns down there at the bottom, because I think, as we discussed earlier in the week, that we didn't have any patterns in that list that were kind of beyond get entity by ID, right? So we've got a couple patterns in here that are going to actually retrieve, entities by date range. They're going to give us, order history or customer history. And so those are going to actually be collections of objects. So that'll be the interesting aspect here, because a lot of these get entity by ID, heck, it doesn't really matter. We can go across multiple tables, right? Since it's just kind of get entity by ID, there's no real efficiency there. But those other ones, those are going to be the real interesting ones. So good set of access patterns, it looks like.
Awesome. Yeah, absolutely. I mean, you can, and with these GraphQL operations, pass in arguments. You can return different types of data, and all you need to do is kind of define how that looks by the types. So, for instance, get customer by ID, we're just going to be returning a single customer. So this is going to be coming back in the form of an object. Get inventory by get inventory by product ID right here. Mm-hmm. That's going to be returning an array, and the array is going to be of type warehouse item. So we would just kind of define it like this. You could also return a string, or you could return an integer, and anything like that. So the type doesn't have to map to an actual type that we've declared. It could be some, data type, like a string, integer, float.
And these types could actually be complex types that contain, properties that are actually other types. And so if we're querying the table and that all those types are present, then we should be able just to kind of assemble those complex objects and hand them back to the application using these direct Lambda resolvers.
Right. And to do something like that, you would probably just create some type that mapped to all of that data. And then you might have a type field on that type,
Yeah, exactly. Like a field on that type, or a property of that type that contains, either one or more or a list of other types. Exactly. So it's really, again, as we kind of showed in the example I showed previously, you're going to get an array of items back from the query, and those items might be homogeneous, those items might be heterogeneous, but at some point you're going to have to map those items into the construct that you queried for, and that construct might be a base entity. That construct might be a collection of entities, for example, an order history, which might contain not just the products that were ordered, but it could contain the invoices and shipments of the order, a variety of things that might happen here. So these entities that we define in GraphQL don't necessarily correlate one-to-one to the actual application layer entities or the data model entities. A GraphQL entity, and this is something that I think was key understanding for me, is that a GraphQL entity really defines it could define a collection of entities, right? A hierarchy of relationships. It's not just a top level item, right? So,
right.
And when I query when I send that down, that definition, that GraphQL definition or query down to the system, that's what we can do. We can actually look at the patterns or the object that the hierarchy that's being requested and map that directly to a query that's going to efficiently retrieve those results.
So, how would we actually, get this information into Lambda? So let's now take a look. What we basically are going to have right here on the right are the resolvers. So you can resolve any query or any mutation into a resolver, but you can also resolve a type field into a resolver. So for instance, if I wanted to resolve this ID from an invoice, I could actually create a resolver, and that resolver would be a Lambda function or some DynamoDB operation or something like that. But we're not really worried about resolving any of the fields, because we're going to be returning the fields from DynamoDB via Lambda. But what we are going to be resolving are all these queries. So if I scroll down and I look at the query type, I'll see that we have all these different fields on the query. And from here, we can just decide, where we want these operations to go. So if I click on one of the resolvers, we see that we have kind of, this new view that we're checking out. But I'm going to go ahead and delete this resolver and just show you how this works. So we're going to go back now, and we have all these resolvers defined. We have all these queries over here defined, and now I want to map this into that function. So how would we do that? I would scroll down here, and I would find the function that I would like to attach. So for instance, we have get customer by ID. I want to map this to a Lambda function. So all it needs to do would be to click attach. And then here, we can view all of the data sources that we've created. And then now I'm going to switch over into one more panel and kind of show you how we created that data source. There's a data sources view in AppSync, and all you need to do is click create data source, and then you would choose the Lambda function that you would like to be created as the data source, and then you would be done. It would then have the ARN connected and the permissions set for AppSync to actually access this function. So I've created this one data source, and all we're doing is just mapping, just a regular Lambda function. And this is going to be the one that we're doing. And that's it. Now we can just click Save Resolver. In the past, though, we would have these request and response mapping templates. And since we no longer need that, those are kind of, the old way of doing things. I can just click Save Resolver, and we're ready to go. And I go back to my schema, scroll down, and I kind of want to match that up again. I see that now that that query has a resolver attached, and we're ready to take a look at our function. So let's go ahead and take a look at the Lambda. What you have going on here is in the handler, you have that event, and the event object is going to be, having some metadata that is specific to AppSync and to GraphQL. So let's go ahead and log that out by performing a query before we kind of walk through the rest of this, just to kind of give you an idea of what's going on there. So to log that out, I'm going to go ahead into AppSync, and I'm going to go into we have a queries editor where we can actually perform queries live onto into our data source. So I'm just going to perform a get order history by ID. We're not going to walk through that just yet. We just want to log out the event. So I'm going to go to Cloudwatch, and we'll take a look at the event. Okay, so here's the event. We have a couple of different properties that we're going to be focusing on. So arguments. If we look at the operation here, we have an order ID. And you'll see that we now have that order ID coming through here in the arguments. So we can get that off of the event. If we were signed in and we had an ID token, this identity would be populated with an object. We have our request headers. We don't really need those for this example.
So these are like test events, not, or is that what this is? What we're looking at right here? The user would put this together to kind of test the API?
Yeah, you can think of it that way, but the event data itself is going to look the exact same.
The exact same way, right?
Yeah.
It's just going to get. So some of these things will be populated when you. I see. Okay.
Yeah. And then the info object is pretty useful. This has a lot of GraphQL type of information. So the selection set list is the selection set data that we asked to have back. So in the query, we said we want the amount, we want the date, and the ID. So that comes through in the event. So if you ever need that for any reason, it's there.
So now, real quick here. So in this particular example of get order history, we're simply getting the top level order item, but the order history on the table contains, invoices and shipments and, order items. And so theoretically, we could simply just extend that request, so to speak. Right now, all we're asking for is the amount, the date, and the ID, but I could have an array of invoices. I could have an array of shipments. And so then, and what's really cool about that is that, once I add those things into this query, then the result set that's going to come back when I query DynamoDB by order ID is going to include all those items already, right? So all we need to really do then is push those things into the object using the Lambda code that you just showed us, right? So we can go back to that code real quick and take a look at. So the code that we got right now kind of doesn't really process multiple items, but there's no reason why the query definition in the result set couldn't handle it, right? Because if you think about the DynamoDB structure on the table, we've got a lot more items in that order partition than simply the top level order item, and we could return those. Right?
Absolutely, yeah. You can work with any type of data, that you could think of, that I can think of.
Yeah.
So And then we have the parent type name. So this was a query, and then we have the field name. And the field name is really kind of what we're going to be focusing on, because we want to be able to understand as quickly as possible, so we can then take the operation and kind of map it into some type of DynamoDB operation.
So now that is parsed by your Lambda process to determine how to query the DynamoDB table. Is that right? So you have basically one Lambda function that can execute all these various access patterns, and that's what you're. When you say field name get order history by ID, we're checking that in the Lambda function. We're making basically a switch on the field name and
Exactly.
saying, hey, if it's get order history by ID, then I want to query the table with the order ID as the partition key, and I'm going to get those results. What we're looking for is the amount, date, and ID in this particular query. So I could actually define a specific, so I don't necessarily have to get all the items out of that partition, right? In this example, since I'm only looking for the amount, the date, and the ID, I could define my get order history by ID to say get query the or by order ID where what I don't know which item holds that. Is that the item that's sorted on customer ID? What is the query that we're running when we go get order history by ID?
So the query on DynamoDB.
Yeah.
So let's take a look at that. Yeah. So to map that into a function and then into DynamoDB, we're basically going to take the field name off of the event. So I'm basically going to, let me go ahead and remove this console.log for now,
Sure.
just to kind of make a little more room. So I'm destructuring the field name off of the event. So this is that field name we just looked at. And then we're just doing like a switch statement. And we're going to say, okay, based on the field name, we're going to then perform this operation. Now, of course, if you are the type of person that wants to have a separate function for each GraphQL operation, you could do that.
Right.
But I think for this example, it made a lot of sense to kind of put them all together so we can view everything at once.
Sure.
So the operation that we did was get order history by ID. So let's go ahead and take a look at that. I have a function called get order history by ID right here. And I can then just go to the function and open that up. And all we're doing here is just a really basic operation on DynamoDB using the DynamoDB document client. So we have our params defined here. We have, we're setting the primary key and the sort key. We're then doing a filter expression on the order.
Got it.
There's only a couple of items that come back for this operation, so it's not really filtering that much. And then this is kind of where we're trying to make sure that the data that we want looks like the data that we've defined in our GraphQL API.
Right.
And we're only making one small modification. And this was only done because I like to have an ID for every item in my GraphQL schema. That is like a unique, ID.
Mm-hmm.
But we could have also used the primary key as the ID or the sort key or some combination of the two.
Sure.
But yeah.
So basically, this would be your logic that loads the response. Basically, at this point, you're going through this thing and you're saying, okay, here's the. Well, actually, is this where is it that we're actually generating the response for the request?
So anything that's returned from the function is the response.
Okay, so now if I had a hierarchical data structure that would be maybe a complex, instead right now we've got a simple, okay, here's we found the item we wanted in the order partition, but maybe there's going to be a complex response that's going to include invoices and shipments. So right. I'm going to at that point, would I return an array? Would I return a map? How would that data go back up to the client to be processed?
You could return either one. It just, I guess, depends on how you defined it in your schema.
I see.
Yeah.
Right, okay. So then on top of this, now does this replace the response mapping template? Does the Lambda function?
Right.
Yes,
Exactly.
Okay, yes. Okay. So there's a response object that would be that would contain the data structure that was defined in the GraphQL query, and that's what we would populate. In this particular case,
whatever data structure you return is the return type, and there's nothing else like. There, like before in the VTL and the response mapping template, there was some other stuff going on. It made it kind of tough, in my opinion, to kind of understand what was going on. But since we're just working with JavaScript or Python or whatever in a Lambda, it's just like you're working with an API call from anything else,
Sure. Okay. So we got another question. Are there plans to make Amplify directives work better with single table design? They seem like they seem to force an entity model. Yeah.
Yeah, absolutely. It is something that it is on our you know,
On the radar, right?
backlog.
Yeah.
It's on the radar. It's even on the backlog at some point, but
Right.
it's not going to be something that's going to happen like in the next few months. But it will be something that is going to happen, and we're already actively investigating it and working on it.
Yeah, well, and again, I think what we're kind of demonstrating right now is that the tools and technologies already exist, right? They existed in VTL, they existed in direct Lambda resolvers. The entity model is not something that goes away. I mean, yes, I believe that Amplify absolutely does force an entity model, but that's actually one of the primary fundamental tenets of data modeling, and it's not something. And if you listen to any of my sessions, that's what do I talk about, right? We can't even start to talk about the data model until we understand the entity relationship diagram, right? So I absolutely agree with this construct of we have a type system, we're going to define our types, we're going to define the hierarchy of those types, and then we're going to query those hierarchies. That's extremely well aligned philosophy that GraphQL has with the whole single table design, with normalized design in general, even across relational databases, right? And again, when you start to look at GraphQL in a relational context, I mean, I could certainly go and query each individual entity table in a relational database and do that, or I could define a complex query and map that to a GraphQL template and execute a parsing response mapping template or a direct Lambda resolver so that I can execute a single query against the relational database to retrieve all the results that I need to hydrate my GraphQL or my GraphQL response, right? As a matter of fact, we're going to go through the exact same process of determining when does it make sense. If you almost look at it like in the relational context, when do I map a GraphQL query to a complex SQL join statement, or versus when do I query a table per entity in the relational model, right? I mean, this is really what we're getting down to underneath the covers. It's like this is the crux of your data layer API, right? Get order history by ID. That is exactly, and so underneath what happens with get order history by ID, that's irrelevant to the developer. All they know is that I'm going to get this information back when I make that request. So giving the developer a decorative construct to define what it is that they're looking for from the data layer is really what GraphQL is about. And mapping those queries underneath, that's how we drive efficiency in the system. It doesn't matter what database you're using, whether it's a relational database or no SQL database. So I agree that we need to make it easier for developers to embrace a single table design, but I totally think that the entity model is a foundation of any application, and Amplify apps actually enforce a best practice by doing that.
Yeah, we definitely get a lot of great customer feedback, and we're always working to prioritize stuff. So yeah, anything else that anyone has that they'd like to share, feel free to reach out to me on Twitter at Dabbit3, or just go to our GitHub repos if it has anything to do with the open source projects, and open up a conversation there.
Yeah. I mean, I love this tooling. I love the, and honestly, like we've talked about, the tooling was there. It was in the VTL constructs, which maybe was a little bit harder for developers to kind of get their heads around. But it was always there. The direct Lambda resolver is really just a way for them to kind of get into an environment that they're very comfortable with, right? I get some context in, I can process the elements that are stored inside of that context and execute and return a response. And they're just I think developers just a little more comfortable with this. It'll be interesting. I think we talked a little earlier about potentially doing a bake-off, right? A shootout between multi-table, single table using, direct Lambda, single table using VTL mappers. Yeah, I mean, we're going to do this. In a couple of weeks, we're going to put some code together. We're going to come back online and we're going to say, okay, let's run some high-velocity workloads and actually show you the efficiency. I would expect to see that the direct Lambda resolver and the VTL response mapper approaches are going to be very, very close. But we're going to see a significant advantage for both of those in a performance context over multi-table. And I think this will really be, what developers need to take home from this. It's like, and it's a lot of it has to do with how we kind of advertise all kinds of features across AWS. It's like, we do things to make things easy for customers. And oftentimes the easy button is all we need, right? It's never going to get painful using multi-table. For 90% of the applications people are building, multi-table is not going to feel any different than single table, right? For that 10% of apps that are scaling beyond, what we would think of as like a single instance application or something like that, things that are starting to get big, that's when we see the benefits of doing these things, right? And so it's up to the customers, right? I mean, sometimes an application is never going to get bigger than X, right? So just go ahead, take the default resolvers, use entity per table, per table models. It's just never going to be anything that's going to bother you. And with on-demand pricing, the complexity of that is and the benefits, the cost benefits are negligible. The complexity difference, is negligible. So it doesn't really matter. And one of the things about the entity per table model is it sure makes things easier for the service to make those assumptions, right? I mean, it's not easy for the service to make assumptions about complex data models, but it certainly is easy for us to build a generic service that can address the needs of a basic entity model, and that's really what multi-table does, right? So I can't say that one is has, I mean, we can always say one has advantages over the other, but when do I use one versus the other? I don't know. I mean, a lot of this is up to the developer.
I think that also with the direct Lambda resolver support, the mental model for people that have picked up something like API Gateway in the past and they've been able to use the proxy to kind of proxy the event directly into a Lambda function and then have access to over 48 AWS services directly from Lambda really easily.
Oh yeah.
It's really easy to kind of take that mental model and start applying it to GraphQL. But here you're actually able to look at your schema and know everything that's going on in your application, because it's almost like a menu. You have all of the different types that are available, all the queries, all the mutations. And mutations work exactly the way we're looking at now. So if you actually wanted to create a CRUD app, or if you wanted to actually have a real-time application based on all of these types. So you could think of if someone created a new customer by ID and you needed to subscribe to that event, all of that's actually already built into the service. All you need to do would be to create a subscription definition here, and the actual subscription real-time implementation's already been baked into the service. So it automatically is going to work. Anything that you return from a mutation in your Lambda function, for the examples that we're looking at, for example, anything returned from that function gets sent as that subscription in real time. So it's the service has so much additional power and benefits to it. I think making this so much easier is it's extremely exciting. I really personally, I'm a big fan of GraphQL. I really am excited about the stuff that I'm working on. But now that we have this, I can't really think of a lot of use cases where I wouldn't use this as my API layer. REST is extremely still powerful, and if you like REST, of course, continue using that. But if you're into GraphQL, this is kind of a really, really nice DX.
Oh, I've becoming much more of a GraphQL fan, honestly, after this last week or so, or two, diving in. A lot of the things that I looked at initially was kind of, whoa, because again, I kind of got struck by this entity per table model, executing complex, patterns of multiple queries to retrieve, data that could be retrieved in a single result set. But now understanding, VTL mappers, understanding direct Lambda resolvers, and how we can actually build this efficiency into the system, it's just another application development framework, right? And just like anything, it's like so many of our systems, it's like, we make assumptions out of the box that aren't necessarily optimized for you. They're not even optimized necessarily. They're just generics, right? Generic assumptions. And this is the entity per table model is the generic assumption that we know, okay, look, a new user comes in, doesn't know what they want. They just want an app that does X. Hey, we can give them an app that does X. You hit this button, right? Is this going to be the end all be all of data models that you want to, run your application at scale with? No. And it's certainly not an exercise that's unique to this service, right? I mean, how many applications have we built over time that have required us to refactor the data model? I mean, it's a common part of the application development experience, right? I mean, we're going to be in the best case, you did a beautiful job, architecting this, sweet data model, and it works perfectly. And now I need to separate it into multiple API services. Okay, what am I doing? I'm vertically partitioning tables. I'm truncating, things out of this catalog and creating and migrating data into new catalogs and creating new APIs on top to scale my service, right? And so, refactoring the data layer is not something that, developers should be completely afraid of. It's something that we should, absolutely understand that as my application grows, I might outgrow the entity per table model. right? It might become painful from a cost performance perspective to use that model. At which point, hey, great, let's refactor this thing. And what's nice about Amplify and AppSync that it does for you, it gives you that abstraction layer that makes it easy to do that, right? I mean, I could say, hey, these queries are costing me. I'm going to migrate this data into single table, and I can do this in stages. I don't necessarily have to bite the whole bullet all at once. I can, as we demonstrated, individual queries map to individual operations map to individual queries through the abstraction layer of Amplify, which gives the developer the ability to throw a switch at any time, right? And say, I'm going to use it from this source or that source, right? So, that's one of the things that we, as an enterprise at Amazon, struggled with and actually came up with solutions for was, how do we deprecate one API in favor of another, and do it in stages, right? As we started to migrate across from our services from relational databases to NoSQL, and so giving customers tools like this, right, where I can actually define these constructs and throw switches to make that happen, it's actually really, really nice, and it's a really valuable feature for developers. So, I don't know. I mean, I actually think it's a very powerful platform, and going forward, it's something I'm going to look more for.
And someone asked for the code, so I'm gonna actually go ahead and link to this gist. I'm gonna have to update this a little bit because it's not completely up to date. But it does have everything that I use for this API. It has the schema, it has the queries, it has the functions, and all of that. I just maybe need to update a couple of things, but I just pasted the link in the chat.
Sure. So we had another question about multiple resolvers and parallel limits and throttling become a concern, as always. And with multiple resolvers in parallel, I'm not all that worried about it because oftentimes those resolvers might be firing in parallel, but they're going across different partitions, right? Get me this order ID, that order ID, get me these things from that, get me these things from the GSI versus the table. So, access patterns are always something you need to kind of consider when you start talking about velocity of data. That's when throttling becomes an issue. So this is something that, we're just going to have to understand up front. I wouldn't say there's any more concern with throttling in a single table than there is in multi-table, right? I mean, I've got the same issues, 1,000 WCUs, 3,000 RCUs, and if I'm hitting them too hard, I'm going to throttle. So this is just something that as a developer, we need to understand and address. As far as how do you help with throttling, DynamoDB has a really, really good tool now. It's called Cloudwatch Contributor Insights. If you enable that on your table, you're going to be able to see exactly which keys are hot, not just which partitions, but which individual logical key values are being requested and how much of your write capacity and read capacity they're consuming. So you can identify which areas might need to be addressed inside of your implementation or find your hot users. And so that's probably the best tool for dealing with that. But again, it's just something that's always a concern. So no matter what application you're building.
So
cool.
Just kind of going through a few more of these queries. It's pretty much the values that we're getting back are of course different, but the fundamental idea is the exact same across all of these. We're taking that argument, we're mapping it into the event. In Lambda, we're then taking that event and we're going to kind of take a look at the event. We're going to see the arguments. We're going to see the operation. We're going to decide at that point which function we're going to hit. And then whatever we get back from that return value is going to populate these fields here. And that's it. I mean, it's actually pretty simple. If you've ever worked with DynamoDB from Lambda in the past, getting this to work is not hard at all. And someone mentioned the authorization. So yeah, AppSync actually has a bunch of different types of authorization modes. Right now, I'm using more of like a public access, which is an API key, meaning you can hit this API from any client application. As long as you send an API key in the header, you're good to go. But you might want to do more secure forms of access. So we also support Amazon Cognito. We support OIDC, and we support IAM. So if you'd like to hit this API from another AWS service, we support that as well. So all of that stuff is baked into the service. And again, that identity will be available in that event, depending on how you hit the API.
Very cool. All right, so there we are. We're running up to the end of the hour here. Great session. Really appreciate you coming on board here for this, Nader. We're going to have you back in a couple of weeks because we're going to do that shootout. And I actually want to work these access patterns a little bit more. I'd rather show some folks that have some real complexity here. How are we hydrating these complex objects that have relationships to arrays or lists or of other objects or properties that exist that are other objects, right? So we'll show that. But this is, again, folks, please put your hands in this. I think this is a really good framework for establishing a very well-defined data layer API. Which is language agnostic, right? That's what GraphQL gives you. It gives you that abstraction. Your developers don't need to understand how the data is being hydrated or where the data is stored or how it's being queried. All they need to know is what do they need to ask for. And in order to do that, what do they need to define? What types of objects they have, right? What are the properties of those objects? Okay, this is what I want in my query statement. And I don't have to understand SQL. I don't have to understand document API and DynamoDB or anything like that. That's for your data layer API engineers. And that's really what Amplify gives us, is this kind of well-managed, well-abstracted data layer API framework. And I really, really like it. So again, thanks so much, Nader, for coming on board. I look forward to seeing you in a couple of weeks when we do the shootout. And if anyone else has any questions, fire away. I don't see anything up there. Give the moderators a minute to let us know if anything else is happening.
Yeah, absolutely. I appreciate coming on. Someone mentioned some Cognito stuff. It would be cool to possibly do some fine-grained access control and authorization stuff in the future. That's something to consider. I think that would be pretty cool.
Cool. All right, then. That's it. Thanks, folks, again for the time, and we'll see you again next week. I don't know if I have a subject yet, but we'll come up with something to let you know pretty soon. And again, thanks, Nader, for your time and your effort on this, and look forward to seeing you again in a couple of weeks. Talk to you later. Bye.